Robots are officially out here throwing hands. No, seriously, one literally lost it mid-demo, started flailing like it had just realized it's been programmed to assemble IKEA furniture for eternity. Engineers scrambled, equipment flew, and yeah, it's all caught on camera. But that clip, just the beginning. From robots breaking bad in factories to humanoids selling cars with creepy sunglasses and customer service smiles, AI and robotics are moving way faster than most of us realize. So today, we're diving deep into the wildest updates, the breakthroughs, the meltdowns, and the moments where science fiction looks way too much like tomorrow. Let's start with the clip that broke the internet. The viral clip came from factory security footage, originally reposted by the Belarusian media group Nexa. Location? Somewhere in China. The robot? A half-finished humanoid suspended from a construction crane, like a marionette, mid-assembly. This was supposed to be a standard motion range test. Two engineers stood directly beneath it, tablets in hand reading servo IDs. Nothing unusual. Until suddenly, everything spiked. Every joint in the robot's frame fired at once. Its arms windmilled, feet kicked, and it yanked the suspension line sideways, dragging its welded stand across the polished factory floor. A desktop PC nearby smashed to pieces. A bucket of fasteners scattered across the ground. Both engineers bolted for safety as the crane hook above groaned from the strain. The entire meltdown lasted about 20 seconds. Within hours, the video racked up over 100,000 views and exploded on social media. One commenter dropped, "Sarah Connor was fucking right," while another posted a clip of RoboCop's ED-249 falling downstairs. Even a surgical resident chimed in, saying it reminded him that a Da Vinci surgical console is still just motors and firmware. But underneath the memes, the footage raised serious concerns. It was a brutal example of how torque values can go rogue when the safety envelope isn't locked down. And it didn't just go viral, it became fuel for a bigger, darker conversation around AI control and mechanical limits. Roughly 500 kilometers west of Shanghai, a Chinese car maker called Chery Automotive is heading in a totally different direction. While some robots are glitching out, theirs are smiling, waving, and offering you bottled water. Chery's latest move? Humanoid showroom staff. Not virtual avatars, real physical androids. Life-size, blonde, ponytailed, and wearing wraparound sunglasses. Think customer service Barbie, built by a robotics lab. The robot's name is Morin, developed in partnership with robotics firm AI Moa back in June 2024. Morin made its first appearance at the Shanghai Auto Show and returned this week on stage behind Chery International President Zhang Yibing, alongside a full lineup of identical bots. Zhang didn't hold back, telling dealers that humanoids have more market potential than vehicles, calling AIMOA the future of the company. He wasn't joking. The price tag? Around mid-five figures, roughly the cost of a car, and over 220 units are already scheduled for delivery in 2025. One is already deployed at a dealership in Malaysia, where it greets shoppers, hands out bottled water using carbon fiber fingers, and answers trim package questions with a smooth, synthetic alto voice. And those sunglasses? Not just a fashion gimmick. They're hiding a surround view camera array that stitches together a full 360-degree field of vision. Each fingertip has capacitive pads to detect when a customer taps on a brochure. One viral video even showed Morin dancing on stage at the Woohoo launch event, sparking a flood of comments, including one that joked about updating the corporate dress code to accommodate plastic blonde. So while robots in labs are snapping mid-demo, Chery's putting androids in the showroom to charm customers with tech and a smile. If China's selling futuristic charm, Germany's selling cold, calculated practicality. The Cologne-based company iGoo's GmbH has unveiled Iggy Rob, a humanoid robot built from 15 years of tribology data. Translation? They've been studying how to make plastics glide smoothly, quietly, and without grease, and now they've turned all that data into a full humanoid platform. Iggy is built from low-friction polymer parts and designed with one goal: cost and equivalent labor. Price tag? €47,999, 0 cents, around $54,500, 0 cents. That's a third of what you'd pay for Agility's Digit and half of Tesla's rumored price for Optimus. Now, Iggy doesn't walk. The humanoid torso is fixed to a wheeled autonomous base called Rebel Move, which includes a 3-point bearing system capable of handling 50 kg of its own mass and an additional 100 kg payload. Mounted on top are 2 Rebel Comet arms, each driven by a 6-axis Monic gearbox stack. Iggy's hands? Bionic, using polymer gears that never need grease. Navigation is handled by a roof-mount LiDAR sensor and dual 3D cameras mounted at eye level. The robot runs for 8 hours on a single lithium battery pack, supports ROS2, and is CEC certified for Europe. It's fully compatible with existing German industrial fleet management systems, like VDA-50, the same dashboards used for pallet movers and tugger robots. IGUS's pitch? Brutally straightforward. They'll ship out a unit for live testing, set it up at a reception desk, a kitchen, or any other operational cell. On the other side of the globe, in California, the University of California, Berkeley is shaking things up. Not with big-budget bots, but with a humanoid anyone can build at home. Their Berkeley Humanoid Light project is an open-source platform designed to make advanced robotics accessible. They've released everything, complete CAD files, firmware, and reinforcement learning scripts, directly to GitHub, all under an NSF grant. The bot stands 0.88 meters tall, toddler-sized, and is powered by 22 cycloidal gearboxes. Everything is printable on any standard home FDM 3D printer with a 200x, 200x, 200 print area. The cost, around $4,312.00 if you're sourcing parts in the US, and just $3,236.00 if you're importing from Shenzhen. The most expensive components are the actuators. 10 high-torque 6512S at $188.00 each, and 12 lighter 5010S at $136.00. The brain is a $120.00 Intel N95 mini PC that drives 4 1-megabit CAN 2 buses at 250 Hz. It runs on a 6-cell 4000 mAh LiPo battery, giving it around 30 minutes of runtime. That may not sound like much, but Berkeley's real edge is in the software. They trained a walking policy entirely in simulation and then deployed it directly to the hardware, no fine-tuning needed. In the demo video, the robot steps off a bench, shrugs, writes its initials with a marker, stacks foam cubes, and even spins a scrambled Rubik's Cube. Solving it? That'll come with firmware version 2. The team also included a performance per dollar metric in the paper's appendix, essentially measuring joint torque divided by height, normalized by cost. According to that calculation, this $5.00 platform beats out several 6-figure commercial robots. The response online was divided. Some saw it as a breakthrough, the Raspberry Pi moment for legged robots. Others pointed out that PLA-printed gear teeth are a recipe for disaster in real-world use. Still, the open-source nature is the point. The GitHub repo is already seeing pull requests for longer battery tubes and different gear ratios. Berkeley's goal? Hundreds of hobbyists iterating, improving, and expanding the design, all without waiting on a corporate roadmap. And with companies rolling out armies of humanoids, some charming, some practical, some terrifying, the question hits harder than ever. How long before one of these machines replaces you at work? What do you think? Comment below. And if you found this video interesting, make sure you hit the like button, and also don't forget to subscribe to our channel for more of these kinds of videos. Thanks for watching.